evaluate this integral. For this one, we're going to let u be negative 4x. Since it's a composite function, we have to use u substitution. If u is negative 4x, then du dx is negative 4. Which means that we have du equals negative 4 dx multiplied by dx both sides. And we can also solve for dx. dx then is du over negative 4. So we're going to use this one, and this one to substitute. So let's see what we get. We have e to the u, and dx is same as du over negative 4. And this du over negative 4, same as 1 over negative 4. We can take it outside of the integral sign to have negative 1 over 4 eu e to the u power du. Remember, when we take the integration, this variable quantity we have has to be same as du. Same right here, du. So here we have dx and dx, right? Here we have to have u and du. Then we can take the integral of this one. Well, negative 1 over 4 is just multiplying afterward. We take the indefinite integral of this one. We can take the antiderivative. Antiderivative u, e to eu is just eu, e to the u power. But here we have to write plus c. For the final answer, we have to plug back in what u is. This right here to right here. So the final answer is negative 1 over 4 e to the negative 4x plus c. This is the final answer. Of course, we can take the derivative of this one to check our answer. If you take the derivative of this, you will get e to the negative 4x. For this one, this is definite integral from 0 to 8 of e to the negative 4x power dx. So we do have to use substitution. So first, let's say let u be negative 4x. Then if we take the derivative of that, du with respect to x, we get negative 4. So we can solve for dx. du is negative 4 dx. dx then is du over negative 4. So what we're doing here is we're substituting this one and this one. So we can have things in terms of u. But also, we have to notice that this 8 and 0 is for x. So when x is 8, for the upper bound, the u will be negative 32. Right? I'll plug a right here. And similarly, when x is 0, u is 0. So we also have to change the bound as well. This too becomes new bounds when we substitute as in terms of u. So let's do that here. Once I substitute this to right here, I get e to the u, and dx is same as du over negative 4. And now upper bound is negative 32 because we have in terms of u, and lower bound is 0. Okay, so then this negative 1 over 4 right here is same as we can take negative 1 over 4 outside of the integral sign because multiplying constant eu du. Now this is definite integral because we have numbers. Therefore, we should not write plus c. We don't need to write plus c. So we take the, let me do it right here. We have negative 1 over 4. Antiderivative of e to the u is e to the u, and we evaluate those from negative 32, plug in here, and subtract, plug in 0. So negative 1 over 4, again, negative 1 over 4 is multiplying after we do the definite integral. So make sure to keep the parentheses here. Plug negative 32 minus e, plug 0. So then what we get is negative 1 over 4 e to negative 32 power, because we're distributing. E to the 0 power is 1. Anything to the 0 power is 1. So we have plus 1 over 4. Since we're multiplying negative 1 over 4 with negative 1, we get plus 1 over 4. And we can rewrite this as negative 1 over 4 to e to the 32 power plus 1 over 4. So this is our final answer. This is a definite integral, so we get a numerical answer. And again, e is just a number. E to the 32 is 2.7 something, so raised to the 32 power multiplied by 4, right? So this is our answer to this definite integral. So when we do definite integral using u substitution, we also need to change our bounds in terms of u, because this is for x. So u was negative 4x. So when x is 8, u is negative 32. When x is 0, u is also 0 in this case. Take indefinite integral of x squared minus 2 times x cubed minus 6x to 207 power dx. So first, we have to use u substitution. So let u be x cubed minus 6x, this portion right here. Then let's take the derivative. Then we get du dx equals 3x squared minus 6. Right? So this is essentially, we have a parenthesis here. So then we can solve for dx. Well, du is 3x squared minus 6 dx. Then we can solve for dx by dividing this both sides, right? So dx then equals du over 3x squared minus 6. So we have u and we have dx in terms of u. So we're plugging those two in to substitute in terms of this integral in terms of u. So let's do that right here. We have, well, x squared minus 2 for now, just stay as it is, times u to the 207 power, u to 207 power, dx is right here, du over 3x squared minus 6. Okay. So we cannot take the antiderivative until we have only in terms of u. So that means we need to do some algebra here. X squared minus 2 multiplied by u 207 du over, here we can factor 3 out. We can factor 3 out to get x squared minus 2. Now we see that this one right here and this one here will cancel out, right? One is on the numerator, one is on the denominator. So this one and this one will cancel out. So what we have left with, we do it this way, we have u to 207 du over 3. So this over 3 is the same thing as 1 over 3. We can take it outside of the integral sign, like this. Now we are ready to take the antiderivative to evaluate the indefinite integral. So 1 over 3 will multiply after we take the antiderivative. This one, reverse power rule. So add 1, 208, add 1 here, and divide by, then added number 1. Added 1, which is 208, plus c. Since it's indefinite integral, we must write plus c. So our final answer is, we can multiply these two numbers. We'll get 624. 1 over 624, u to the 208 plus c. Okay. But again, the final answer must be the variable that was given with. It starts with x, right? So it has to be in terms of x. So what is u? U is this. So we can plug this right back in right here for the final answer. So the final answer is 1 over 624 times x cubed minus 6x raised to 208 power plus c. Oops. So this is the final answer. Again, we can check our answer by taking the derivative of this, and you should get this right here. Indefinite integral of e raised to the cosine x times sine x dx. So let's let u be cosine x, then du dx equals negative sine x. Then we need to solve for dx, right? Well, du equals negative sine x dx, dx equals du over negative sine x. So using these two, we substitute to the integral. So we have e, well, instead of cosine x, I'm going to write u. Well, we're going to keep the sine x for now. And what is dx? Dx was this. Du over negative sine x. And you see that this sine cancels out. So, but don't forget the negative sign. Negative sign is still here. So we have negative e to du, which is the same thing as negative outside of integral, then integral e to du. Now we can take the antiderivative of this, which is negative e to du plus c, because it's indefinite integral. And we have to substitute back what u is in terms of x. Well, it's cosine x. So our final answer is negative e cosine x plus c. Final answer. And you can check your answer by taking, if you take the derivative of this, in fact, you'll get this, right? You can use a chain rule. Right? This is definite integral from 0 to pi over 2 of e to the cosine x sine x dx. So first we need to use u substitution. So let u be cosine x, and du dx equals negative sine x. And then let's solve for dx. Well, dx then will be du over negative sine x. So we have u and dx in terms of u. We also need to change this bounds. This is for x. When x is pi over 2, what is u? U is cosine of pi over 2, which is 0. Okay, so this is the upper bound now. 0 is the upper bound. When x is 0, what is cosine? U of cosine of 0 is 1. So now 1 is the lower bound. So when we substitute, not only we substitute the u and dx, but also the bounds. So we have, okay, this is 0 right here, and 1 is the lower bound. And e cosine of x is now u, so we put u here. And we keep the sine x dx, sine x for now. And dx is same as du over negative sine x. And you see that this sine x and negative sine x and this sine x cancels out, but keep the negative sign, right? Don't forget the negative sign. So we have 1 to 0, negative e to du, which is same as negative 1 to 0, du. So we're taking definite integral. So for this one, we don't need to write plus c, negative of e to the 0. You know what, let me actually write the antiderivative first. It's e to the u of 0 to 1. Because antiderivative of e to the u is just e to the u, right? So then I plug negative, so maybe you should write it this way. Negative of e to the 0 minus e to the 1. Anything to 0 power is 1, so this is just 1. So we have negative 1 minus e, which is, distribute the negative sign, negative 1 plus e. So this is the final answer. And this is a numeric answer. This is a number, right? Because we found the definite integral, we get a numerical answer. Indefinite integral of 3x over x squared plus 1 to the 7th power dx. So first we need to let u be x squared plus 1. Then du dx equals 2x. Then du is same as 2x dx. We can solve for dx. dx equals du over 2x. So using this u and dx equals du over 2x, we need to substitute. So let's do that. Well, now this, we're going to substitute 3x over, well, this entire thing is u, so u to the 7th power. dx is same as du over 2x. You can see that this x is cancelled out. So we have 3 over u dx over, sorry, not dx, du over 2, which is same thing as 3 over 2 u, oops, I forgot 7 here, 7 du, and we can take this 3 over 2 outside of integral sign. So 3 over 2 integral, then we have 1 over u to the 7th du. Then we can rewrite this u to the 1 over u to the 7th to the u to the negative 7th power, so we can reverse the power rule. So then let's take the antiderivative of this right here. We get 3 over 2 u to the add 1, which is negative 7 plus 1. Negative 7 plus 1 is negative 6. And also divide by the number. And because this is indefinite integral, we must write plus c. So then we can rewrite this as, well, this can simplify, right? 2. So we have 1 over negative 4. And we can also bring u to negative 6 to the denominator and make a positive exponent like this. So then final answer is negative 1 over u is same as right here, x squared plus 1. So we need to plug back in to 6th power plus c. So this is our final answer. Well, I mean, this negative sign can be either here, only in the numerator, only denominator, or in front of the entire fraction, right? It means the same thing. So this is the, again, we can take the derivative of this, and you should get this right here if you take the derivative of this. Indefinite integral of 2x cubed over 3x to the 4th power plus 1 dx. So let u be 3x to the 4th plus 1. Then du, take the derivative of u with respect to x. We get 12x to the 3rd power. Then let's solve for dx. Well, du equals 12x cubed dx. Then dx is du over 12x to the cube. So using this to right here, we're going to substitute. So this will now be 12x cubed over u dx is du over 12x cubed. And you see that this 12x cubed cancels out. So what we have left is 1 over u du. So what is the antiderivative of 1 over u? Right? This one, we cannot reverse the power rule because then we have u to the negative 1. If we add negative 1 to 1, we get 0 power. And divide by 0 doesn't make sense, right? So to remember that derivative of natural log is 1 over u, right? Here we put absolute value sign because inside of natural log always has to be positive. Plus c. Okay, so then finally, we have to substitute what u is right here in terms of x for the final answer. So if ln of 3x to the fourth plus 1 plus c. So here, for the final answer, well, because this is already positive here, x to the fourth always positive, we don't need to write absolute value sign. So this is our final answer. Okay, if you take the derivative of this one, you will get this one, right? When you take the derivative of this, we need to use the chain rule, right? Then you will get this. So indefinite integral of negative 3x plus 4 times e raised to negative 3x squared plus 8x. So here we're going to let u be the exponent right there, this one right here. Negative 3x squared plus 8x. Then du dx is negative 6x plus 8. Then du is negative 6x plus 8. Don't forget the parentheses here when we multiply dx both sides. Then dx, so for dx, divide by this both sides, we get du over negative 6x plus 8. So let's substitute using this one and this right here. What do we get? Well, this one, for now, it stays negative 3x plus 4. E raised to u power, because that's what this entire thing is u, right? Dx is same as du over negative 6x plus 8. So right now, it doesn't seem like things are canceling out, but we can do some algebra here. Negative 3x plus 4 e to du over, we can factor 2 out here. 2, then we get negative 3x plus 4. And then we can see that negative 3x plus 4 here and here will cancel out. So what we have left is e to du over 2. And over 2 is the same thing as 1 over 2. So I can take it outside of the integral sign like 1 over 2 here. E to du. Now we're ready to take the antiderivative. Well, antiderivative of e to du is just e to du, right? So we have 1 over 2 e to du. Now plus c, because it's indefinite integral. For the final answer, we need to plug back in what u is. 1 over 2, oops. The final answer is 1 over 2 e raised to u is this one right here. Negative 3x squared plus 8x plus c. So this is our final answer. Again, if you take the derivative of this one, in fact, you'll get this right here. This one is definite integral from 0 to 2 of the function negative 3x plus 4 times e to the negative 3x squared plus 8x dx. So first we need to do u substitution. So let u be negative 3x squared plus 8x. Then du dx is negative 6x plus 8. So for dx, we get du over negative 6x plus 8. So we'll have to use these two to substitute. But also we need to change the bound. The bound of 0 and 2 is in terms of x. So when x is 2, what is u? u is, plug 2 here. Negative 3, 2 square plus 8 times 2. This is negative 12 plus 16 gives us 4. So now 4 is the new upper bound. So let's keep that in mind. When x is 0, what is u? U is, maybe I should do this way. U is negative 3, 0 square plus 8 times 0, which is 0. So 4 and 0 are new bounds. So when I write this, substituting in terms of u, we have 0 and 4 now. So 4 from here, 0 from here. So then we have negative 3x plus 4 e to the u dx is same as this right here, negative 6x plus 8. We can factor negative 2 here, or positive 2. We get 2 negative 3x plus 4. So then we'll see that these two will cancel out. So what we have left here is 0 to 4 e to the u du over 2. D over 2 is same as 1 over 2, so I can take that outside of integral sign like this. So then let's take the antiderivative. Antiderivative e to the u is just e to the u. So e to the u, and we evaluate 4 and 0. So here, we already wrote 4 and 0 in terms of u. So we do not need to substitute u as x. We don't need that here. So we just plug directly in. So we have 1 over 2 e to the 4 minus e to the 0. Well, e to the 0 is same as 1. So we have 1 over 2 e to the 4 minus 1. So we can distribute this 1 over 2 e to the 4 minus 1 over 2. So this is our final answer. So when we're doing definite integral, make sure to change the bounds. And we don't need to plug back in y in terms of x because we already took care of that right here. Indefinite integral of e to the x over e to the x plus 1 dx. So here we're going to let u be entire denominator, e to the x plus 1. Then du dx is e to the x. So for in terms of d to the x, dx, we'll get du over e to the x. So we're going to substitute using these two. Let's see what we get. We'll get, well, e to the x here stays for now. Entire e to the x plus 1 was u, right? Right here. Dx is same as du over e to the x. And you see that this e to the x cancels out. So what we have is du over u, which is same as 1 over u du. Therefore, when we take the antiderivative of this, is natural log of u plus c. We put absolute value sign because inside of log only can be positive number. No negative, no 0. So then we do have to substitute back in for indefinite integral. What is u? U was this. So plug this right here. We'll get ln of e to the x plus 1 plus c. Oops. Here, we don't need to write absolute value sign because e to the x is always positive. Right? 2.7 something raised to x is always a positive number. Plus 1 also positive. So this is our final answer. So indefinite integral of cosine x times sine fifth x dx. So here we're going to let u be sine x. Okay. And du dx, then derivative of sine is cosine x. Then du equals cosine x dx. Then let's solve for dx, divide by cosine x both sides. We'll get du over cosine x. So using these two, we're going to substitute. So we can have integration in terms of u. So this is, well, cosine x stay as it is. We have sine x to the fifth power. So we have u to the fifth power now. Right, so let me remind you the side. Sine fifth x is same as sine x entire thing fifth power, right? So we have u to the fifth power. What is dx? Dx is this right here. So write that in du over cosine x. And wouldn't you know it, this cosine x cancels out. So we have u to the fifth du. So at this point, we're reversing the power rule. Add 1, divide by the number, and don't forget c. Now for the final answer, we have to plug what u is. Oops, sorry. In terms of x, so we need to plug this back in right here for the final answer. So the final answer is sine x to the sixth power over 6 plus c, which we can write it as sine sixth power, sine x to the sixth power over 6 plus c. So this is the final answer. And if you take the derivative of this, you will get this. Okay. So this is a definite integral. So first, let's pick the u. Let u be x plus 1. Then we'll get du dx equals 1, right? Derivative of x is 1. So we'll get du equals dx. So dx and du are the same for this problem. So this one, let me actually do step by step first. So let's plug these two first and see what happens. All right, so I get, I'm not going to do the bounds yet. So I get x over square root of u dx, right? So x doesn't cancel out here, right? So what we can do is, if you look at this right here, u equals x plus 1. That means x is, I can subtract 1 both sides, then I get u minus 1. So I can also plug u minus 1 right here. Okay. So then we get u minus 1 over square root of u dx. Now everything is in terms of u, right? Write it a little better. Well, we need to change the bounds now, right? So for bounds, we can also use like this notation. When x is 15, what is u? 15 plus 1 gives us 16. When x is 0, what is u? 0 plus 1 gives us 1. So these two are the bounds now. So I'll write 1 and 16 here. So we have everything in terms of u. So this was kind of like substitution work. Let me kind of divide here so we can have rooms. So then how do we deal with this one? So we can just rewrite it before we take the antiderivative. This is same as u minus 1 multiplied by u to the negative half power, right? Because this is positive half power brought to the numerator. Du, I'm sorry. I forgot to write du here. This should be du. Du and dx are the same here, right? For this problem, right here. So then we can distribute this here and here. So we have 116 u times u to the negative half power minus u to the negative half power du. So this one is once implied, so we can add these exponents. U to the positive half power minus u to the negative half power du. So now we're ready to take the antiderivative. Okay. So this one gives us u, add 1, 3 over 2, divide by the number, right? Minus, add 1, which is half. If I add 1 here, I get positive half. Divided by the number. And again, we don't need to write plus c because this is definite integral. We'll get a numeric answer. So this one, well, dividing by 3 over 2 is same thing as multiplying reciprocal. So we'll get 2 over 3, u 3 over 3. Oh, I forgot, let me write this here, 116. Minus 2 times u to the half power. Evaluate 16 and 1 of this entire thing. So I'm going to plug 16 first, and then subtract when I plug 1. So let me set that up on the next line. Here I'm going to plug 16. Then I'm going to plug 1 in and subtract. So plug 16 here first. 2 over 3, 16 to third power. Minus 2 times 16 half power. Again, that number comes from the upper bound. Minus 2 over 3, 1 to 3 over 2 power, 2 u, oops, not u, sorry, 1 to half power. And then 1 comes from right here, the lower bound. Right here. Oops, sorry, I copied on this number wrong. Oops. Didn't mean to erase the whole thing. Okay, it's better. So this should be 3 over 2. 3 over 2, right? I wrote it backward before, so fixed it. Yeah, so now let's just evaluate this. This is 2 over 3. This we can think as 16 third power to the half minus, this is square root of 16, which is 4, right? 4 times 2 give us 8. Minus, here we have to keep parentheses for now, right? Because we're subtracting this first. Well, 1 to anything power is 1. Right? So we have just 2 over 3 minus 2. So let me bring that here. 16 cubed gives us 4096 to the half power minus 8. Let's distribute the negative sign. Minus 2 over 3 plus 2. Now, square root of this number is 64. Okay. So if we simplify this with the common denominator, we get 128 minus 3 over 3 over 18 over 3 minus 2 over 3 plus 6 over 3. Oh, sorry, this should be 8. This should be 24 here, sorry, 24. Which will give us, the numerator is 108 over 3, which is same as, this simplifies to 36. So this is our final answer right here. Okay. So here, when we're doing u substitution, when we come at first step right here, we could tell that there's no way this x could cancel out. But because we know u equals x plus 1, we can also solve in terms of x. X is u minus 1. Okay. So you can do that. You can do all this at all once to get here. I mean, add this step by step, but you can substitute u and x. So you can substitute x plus 1 and x all at once and start from here. And then we broke it down. Well, we simplify before we took the antiderivative, right? Up to here. And don't forget, when you do definite integral, we use substitution. You also have to change the bound. Oops. It was 0 to 15, but it changed to 1 to 16, right? So always keep in mind, change the bounds when you're doing use substitution, definite integrals. So for this is a definite integral from 0 to 3 of the function e to the x minus e to the negative x over e to the x plus e to the negative x dx. So first we need to let u be the entire denominator. So e to the x plus e to the negative x. And then we take the derivative of this, du dx. Well, derivative of e to the x is just e to the x. Derivative e to the negative x is negative e to the negative x by chain rule. Because derivative of e to the negative x is e to the negative x, then we multiply by derivative of negative x, which is negative 1. That's why we get negative right here. So let's solve for dx. Well, du equals e to the x minus e to the negative x dx. Then dx equals du over e to the x minus e to the negative x. So we'll use this and this dx to substitute. But we also need to change the bounds, right? So we have 0 and 3, which are for x. So we need to write in terms of u. So when u is 3, we have e to the 3, I'm plugging 3 here and 3 here, plus e to the negative 3. Okay. And for this one, this is as simple as we can write it. E to the 0 is e to the 0 plus e to the negative 0. Negative 0 is 0. So we have e to 0 plus e to 0. And anything to the 0 power is 1. So we have 1 plus 1 equals 2. So these two are the bounds now. So using those, let's substitute this right here. Well, we have 2 to e to the 3 plus e to the negative 3. And numerator for now, stay. So write it. Over denominator was u. And dx is this right here. Du over e to the x minus e to the negative x. And you see that this two cancels out. So what we have left here is 2 to e to the 3 plus e to the negative 3 du over u, which is same thing as 1 over u, right? This is 1 over u du. What is antiderivative of 1 over u? Is natural log. Right? So we have natural log of u. Evaluate at 2 to e to the 3 plus e to the negative 3. So we plug this in here and subtract after we plug this in. So we have ln of e to the 3 plus e to the negative 3, which is positive number. Positive number plus positive number give us positive, right? Minus ln of 2. So this right here is the final answer. Definite integral. So for definite integral, we have to plug the lower and upper bound, right? And subtract from each other. And it has to be this order. The top one minus the lower bound evaluated of the antiderivative. Indefinite integral of 1 over square root of x times square root of x plus 1 dx. So for u, we're going to let u equals square root of x plus 1. This right here. Well, this is the same thing as x to the half power plus 1, right? So then we can take the derivative du dx is half x to negative half power. Because derivative 1 is 0, right? And we subtract 1 using power rule. So before we solve for dx, let's write it as square root. So this is 2 over square root of x. We can bring this to the denominator, make a positive exponent, and half power is x, square root of x. So then we can solve for dx here. Du equals, we can multiply dx both sides, and then we multiply this 2 square root of x both sides. So then dx equals 2 square root of x times du. So using this right here and this right here, we're going to substitute. So this will be 1 over, let's skip the square root of x here. We're not substituting this directly. But we know this is the same as u right here. U and dx. Dx is same as 2 square root of x du. And we'll see that this square root of x cancels out. So what we have left is 2 over u du. And we can take the 2 outside of the integral sign, so we have 1 over u du. And what is the antiderivative of 1 over u? It's ln of u. This is indefinite integral, so we must write plus c. So for the final answer, we have to plug what u is. U is this right here, so we have to plug this right here. So we have 2 ln of, well, absolute value is because inside of natural log always has to be positive. But square root of x plus 1 is already positive. It's always positive, right? Square root always gives a positive number. So plus c. So this is the final answer in indefinite integral of this function right here. So that means if I take the derivative of this function, we should get this right here. This is a definite integral from 0 to 1, x times e to the negative 3x squared dx. So first we need to do u substitution. So let u be negative 3x squared. Then du dx is negative 6x. So let's solve for dx. Du equals negative 6x times dx. Well, then dx is du over negative 6x. Du over negative 6x. Okay. So we got du, u, and dx. But we also need to change the bound in terms of u. These are for x. So when x is 1, what is u value? Plug 1 here. We'll get negative 3. When x is 0, what is u? Is also 0. So now this is our new bound. So we also need to plug these two in. So let's plug that right here. We have from 0 to negative 3, x e to the u, because that's what we decide u to be. And dx is du over negative 6x. And we'll see that this 6x and x cancels out. So we have 0, negative 3, e to the u du over negative 6. This negative 6, we can take it outside of the integral. So we have negative 1 over 6, 0 to negative 3, e to the u du. Okay. So then, now we're ready to take the antiderivative. So let's take the antiderivative of this right here, which is negative 1 over 6. We're going to multiply afterward. Well, antiderivative of e to the u is just e to the u. Evaluate at negative 3 and 0. So we have negative 1 over 6, parenthesis, e to the negative 3 minus e to the 0. Well, e to the 0 is 1, so we have negative 1 over 6, e to the negative 3 minus 1, which is, we can distribute this. Negative 1 over 6 e to the negative 3 plus 1 over 6. And we can write this as a positive exponent denominator. Like this. So this is our final answer. Definite integral So this is just a number. E to the 3 is number. And we raise e to the third power. So it gives us a fraction, and we add it to another fraction. So this is a number, because definite integral will give us the numerical value. So let's look at this indefinite integral. So we're going to let u equals square root of x, which is same as x to the half power, right? So that we can take the derivative. Du dx equals half power x to the negative half power, which we need to rewrite it in terms of square root before we solve for dx. This is the same as 1 over 2 square root of x. And let's solve for dx. We can actually do cross multiply here, right? When we have a fraction and when we have equal sign, we can do cross multiply. So we have dx equals 2 square root of x du. So using this 2 right here, we're going to substitute, and let's see what happens. So this right here, we have integral sine of u now, right? Not square root of x. U is the input. Over square root of x. Dx is same as 2 square root of x du. And we'll see that these 2 cancels out. So what we have left is sine u times 2 du. We can take this constant outside. So we can 2 integral sine u du. Now we're just taking antiderivative of sine, which is negative cosine. So we have 2 times negative cosine u plus c, which is negative 2 cosine u plus c. Sorry. But for final answer, we need to substitute back what u is. U is this right here, so we need to plug this right here for the final answer. So the final answer is negative 2 cosine of square root of x plus c. This is the indefinite integral of this function. So that means if you take the derivative of this function, you get this right here, sine square root of x over square root of x. So let's look at this indefinite integral. So first, we're going to let u equals x squared plus 2, just this inside portion. So then we know that du dx is 2x. Let's solve for dx is du over 2x. So using these 2, we're going to substitute and see what happens. We have x cubed over u squared. Dx is du over 2x. So here only one of them, 1x cancels out with this. So we have x squared here. So let me write that here. We have x squared u squared du over 2. Well, we can put this 1 over 2 to the outside. So we have 1 over 2 x squared u squared du. So here we have both x and u, which you cannot have before we take the antiderivative, right? So we need to do something else here. What can we do about this x squared right here? Can we write that in terms of u anyway, in some way? Well, then we refer back to here. We know that u equals x squared plus 2. U equals x squared plus 2. That means that x squared is u minus 2. So we can put u minus 2 instead of x squared right here. So that our next line is 1 over 2. X squared is u minus 2 over u squared du. Now we have everything in terms of u. So then we can simplify. This is u over u squared minus 2 over u squared du. Well, u over u squared is 1 over u minus this one. We can rewrite it as 2 to the u negative 2 power du. Take the antiderivative. what antiderivative 1 of u is natural log. And for this one, we just reverse the power rule. So we add 1, which is -1, and divide by the number, plus c. So let's simplify. This is +2. -2 divided by -1 is +2. U to the -1, we can write it as in the denominator and +1 power, like this, plus c. So let's distribute to 1/2. We get 1/2 ln u plus 1 over u, because 1/2 times 2 over u gives us 1 over u plus c. Almost there, right? Final answer, we have to substitute what u is. U was this. So our final answer is 1/2 ln of x squared plus 2. Here we don't need to write absolute value because x squared plus 2 is already positive. Always positive, right? Square and add a number. Plus 1 over x squared plus 2 plus c. So this right here is our final answer. That means if I take the derivative of this function, we'll get this. Let's look at this indefinite integral, sine inverse of x over square root of 1 minus x squared dx. Let me note one thing here. Sine inverse of x is same as arc sine. So we can also write it this way and do the problem. Okay. This is not 1 over sine x. That's different. This is sine inverse. This means arc sine x. So here we're going to let u be sine inverse of x. Then du dx. We take the derivative of sine inverse, which is 1 over square root of 1 minus x squared. Then we can do cross multiply to solve for dx. Well, dx equals square root of 1 minus x squared times du. So using these two, we can substitute to solve for, substitute so we can write in terms of u. So this becomes u over, this one for now, write it. Dx is this right here, square root of 1 minus x squared du. So these two will cancel out. So what we have left is u du. So now we're ready to take the antiderivative, which is u squared over 2 plus c. This is indefinite integral, so don't forget plus c. Then we have to plug what u is. What is u? U is sine inverse. So sine inverse of x, entire thing square over 2 plus c. So this is our final answer. We absolutely cannot combine these two exponents. They mean the different things, right? If this is confusing, you can just write it this way. Arc sine of x, entire thing square over 2 plus c. This is also acceptable. Either one's fine. But here, this is not -1 part. This is representing sine inverse. So if you take the derivative of this function, we'll get this. Indefinite integral of tangent x dx. So for this one, first, we need to rewrite this as sine x over cosine x dx. So then we can use u substitution. So let u equals cosine x. And we know that du dx equals negative sine x. So for dx is du over negative sine x. So using this two, we can substitute. we get sine x over u, because cosine x is u. Dx is this right here, du over negative sine x. Well, these two cancels out. So we have du, well, let me write it as 1 over u du over negative 1, this negative. Well, we can take this negative outside of the integral sign, so we can have just 1 over u du, negative integral of 1 over u du. Okay? And we know, right, we know that antiderivative of this 1 over u is natural log. So we have negative natural log of absolute value of u, indefinite integral, so don't forget plus c. For the final answer, we need to plug what u is. What is u? U is cosine x. So plug this right here. So we have negative ln of cosine x. Here we need to keep the absolute value because cosine x could be negative. Depends on the angle. Right? So this is the final answer. So in fact, if you take the derivative of this, that means we'll get tangent x. Let's look at this indefinite integral. We're going to let u equals x cubed minus 1. Then du dx equals 3x squared. What is dx? Dx then, we can always think as it's over 1, so we can do cross multiply. Dx equals du over 3x squared. So let's use these two to substitute. Let's see what we get. We get integral of x squared over square root of 1 minus u squared. Dx is du over 3x squared. And we see that this x squared cancels out. So what we have left is, I'm going to actually take this 1 over 3 to the outside. So I have 1 over 3 1 over 1 minus square root of 1 minus u squared du. So what is this? So we have to look at this, and what is antiderivative of this? That means if I take derivative of what function, do I get this form? Right? That is arc sine, right? So we have 1 over 3 arc sine of u plus c. Right? If we take the derivative of, for example, arc sine of theta, derivative of that is 1 over square root of 1 minus theta squared. Right? So that's what we're using here. But for final answer, we need to plug what u is. U is this right here. So plug this right here for final answer. Write it right here. Final answer is 1 over 3 arc sine of x cubed minus 1 plus c. So that means if I take the derivative of this function, I should get this right here. Let's take indefinite integral of this function. We're going to let u equals e to the x. Then what is du? Du is, du dx equals also e to the x. What is dx then? Du over e to the x. So let's use these two to substitute. Let's see what we get. We get e to the x over, here is, this is e to the x square, the same thing. So we can write u square plus 1 over du over e to the x. So now you might have just noticed, why didn't I plug u here, right? So I could have done this. So let's see if I did there. So if I put u here, then this e to the x doesn't go away, right? But if I kept it as just e to the x, we see that these two actually cancels out, right? So for this one, we only plug u to this one right here, since this is e to the x square. Okay. Or you could have plugged it here like I did, plug in first u, and then notice that something has to cancel, then plug back in what u is. So they're the same thing. So then we get 1 over u squared plus 1 du. Okay, so what is this form? Antiderivative. What's antiderivative of this? Which means derivative of what function gives us 1 over u squared plus 1? That is arctangent, right? So we have arctangent of u plus c. But for the final answer, we have to plug what u is, which is this right here, in terms of x. So final answer is arctangent of e to the x plus c. So this is the final answer. That means if I take the derivative of this function, I should get this.